Glad to have you here, Spencer. How you started Cockroach, what that journey's been like.
Maybe the unusual thing about Cockroach is when we got started with the company, it wasn't a fully baked product. So most of the product development was done after we raised money. Before Cockroach, I had a 10-year stint at Google. So we actually got to almost look into a crystal ball when we faced Google's challenges and opportunities in the knots.
It's this repetitive work that we need to do against the database that really just gets me and makes things super irritating. And so one layer above that, assuming that there were folks like you who are solving problems one layer below that to make sure that scales, but it was kind of becoming apparent over the last few years that, we're on that journey now where the underlying systems are starting to scale.
Like a global entry point that's free. So that led us to say, well, the only way we're going to do this is if we build virtualization into Cockroach. And that led us to the idea of serverless.
What is that framing that you would want to provide to an architect today, right? In the way that they should now start thinking about their application if they're trying to go serverless and be global from kind of day one?
That's a great question.
Hi, everyone. Welcome today. We've got Hasura hosts Cockroach Labs. This is serverless data for APIs and product development at the edge. We're excited to have Spencer Kimball, co-founder and CEO of Cockroach Labs, and Tanmai Gopal, co-founder and CEO of Hasura, with us. So without further ado, I'm going to kick things off and hand it over to our speakers.
Glad to have you here, Spencer. Maybe just to kick things off, would love for you to do just a quick introduction to what you've been up to, how you started Cockroach, what that journey's been like. We can spend a few minutes there and then dive into kind of our themes for the day.
Okay, great. Now I'll try to make the bio relatively succinct. So Cockroach is 7 years old now. The project's 8 years old. So we launched it on GitHub before we started the company, which I guess is not unusual. Maybe the unusual thing about Cockroach is when we got started with the company, it wasn't a fully baked product. So most of the product development was done after we raised money. Before Cockroach, I had a 10-year stint at Google. And it was at Google that I really came face to face with a lot of the problems with databases, in particular for Google's use cases back in 2002 and to 2012. And those are actually the same kinds of use cases that virtually all successful companies are grappling with now in 2022. So we actually got to almost look into a crystal ball when we faced Google's challenges and opportunities in the knots. And then, the rest of the world's caught up. The global public cloud gives everyone the advantages Google has, but you need to have the infrastructure that's similar to what Google built in order to really exploit it. So that's really the journey that took me to Cockroach. And there was and interestingly, in those other startups, databases were our biggest problems as well. In one, we used DynamoDB and really struggled not having transactions and not having SQL to manage complexity. And in the other, this was .com day, trying to sort of manually shard Postgres and Oracle instances. And so again, it was database my entire career. And interestingly, I took one database class in college and didn't really think it would ever have any relevance to my interests. But here I am 25 years later, still working on databases.
That's awesome. It's interesting. It was very similar journey for me as well, in the sense of having worked on a bunch of different kinds of problems and different kinds of applications, realize that it's this repetitive work that we need to do against the database that really just gets me and makes things super irritating. And can we automate a chunk of that? So one layer above that, assuming that there were folks like you who are solving problems one layer below that to make sure that scales, but it was kind of becoming apparent over the last few years that we're on that journey now where the underlying systems are starting to scale. And so for us, that kind of problem became to say, can we start automating one layer above that so that the whole stack just kind of works end to end, right? But that's awesome to hear. Over the last 7 to 8 years, how has kind of your thinking around what modern application developers need from the next generation of OLTP databases How has that thinking evolved for you over the last 7, 8 years? Like what are the kind of things that you've seen that have, from a market point of view, that have evolved your thinking in the way that you think about, where the product sits and how the industry is changing?
It's a great question, because there have been a number of inflection points in our understanding of the opportunity and the challenges faced by customers. And I'd say the first one was whether we should be NoSQL or SQL. Because when we started, I started the original design doc and things, I didn't really understand how to build a SQL database. It's not something I ever really worked on. I understood the purpose of them. Right. And I'd say the purpose, it's not just transactions or ACID, transaction semantics. That's what some people think. But it's very easy to add transactions to a NoSQL system. And it's kind of mind-boggling that they weren't added long before Mongo finally got them in 2018 or whenever they did add them finally. Because there's no reason they shouldn't have them. And Google had a Megastore product that had a sort of version of transactions that were very helpful and required actually to build something. But I think the more interesting thing about SQL, which I realized in the process of building Cockroach, is just that it manages complexity. There's all kinds of different scalability challenges. One of them is the scalability of your applications. And, you start in day one and to year one, and you're building that first iteration, and you got your chief architect and all your developers. Everyone understands the use case. And you say, okay, this could be eventually consistent. We understand that. This part needs to be transactional, because we certainly don't want to deal with inconsistencies. People have their heads wrapped around the problem, and so they build very intentionally. And you can have a heterogeneous mix of different systems interacting when you really understand the problem. Fast forward 5 years, and it can be extraordinarily difficult to understand exactly what all the ins and outs are, like who's relying on the semantics that are there, what's the data model is shared across different systems where you're streaming data. These things can become like sort of arbitrarily complex, and they create a cumulative tax, like a toll on the end user. And SQL, as much of a pain in the neck as it is to do your data modeling up front and to really explicitly manage your schema and constantly migrate things, potentially have to migrate backwards, it's just a lot less flexible than having a NoSQL system where you just sort of willy-nilly change your JSON models and so forth. And but the reality is that explicit control really does help accommodate complexity as your application use case scales. So another realization we had early on, by the way, Cockroach started NoSQL. We only added SQL when the company really got underway and we started hiring people who came in, including my co-founder, who's also my brother-in-law, Peter Mattis. He looked at what we were doing and was like, we've got to build SQL, because that's really what the market is looking for. That's what all the companies are going to pay us money, not all of them, but a big fraction of them. That's really what they demand. So that was an early transition. And boy, deciding to build a SQL system in your database is a heck of a lot harder than a NoSQL system, like just immensely more difficult. In fact, we've been working now for 7 years of the 8 on SQL, and it continues. It's actually probably our biggest single area in terms of the sort of focus. And then a little bit later, actually not too long, about 2 or 3 years into starting to really get the product to beta level, because I mentioned earlier, we did most of the real development to get from alpha to beta when we were still a startup, and to get to general availability. The next big realization was that, and this was something we saw at Google, but we hadn't really set out initially to build, is that many companies are either beginning to struggle or absolutely will need to struggle with the problem of global architectures, like really accommodating users that are in a different continent, but wanting to not have to build a different version of your service for Europe. You want Europe and America, or United States or North America or whatever, to share the data. It wants to be holistic. And you don't want to have an Uber France and an Uber United States and an Uber Canada or whatever. That would be pretty painful in terms of the user experience, but also the operational cost of scaling that. So that actually led us to think about, well, we can partition data, and that's often a way you want to do it. And then that led you to say, well, there's other use cases like Twitter, for example, where you want to post all the data publicly, and you'd like that to be as consistent as possible and have very low latency, no matter where you access it around the world. And so you just start thinking about things with geographic latency, and that complexifies the whole task of building the database, but in a way that's super useful for the users. And then most recently, and this is where I'll end, because there have been other ones, but these are sort of some of the big, not pivots, but sort of expansions of our understanding of the problem space. But we realized that Cockroach, as we originally conceived it, which was scalability, data intensivity, global scalability, resilience, so that you can, that was the original set of ideas. But then we started realizing, wow, it can be extraordinarily expensive to use Cockroach in a global configuration. Let me just give you an example. You have 5 regions around the world, and you want 3 availability zones in each region for geo-replication. That's fast in terms of the latency. You're talking about 15 data centers.
Yep.
And then you want to have probably a couple VMs in each data center, and you need a Kubernetes cluster in each one of those. So 15 Kubernetes clusters, all of which cost something. You need local load balancers for those VMs that are in each data center. You need a global load balancer to sort of send the data around, balance the connections and things. So you're talking about a cost structure to be in 5 regions that is going to be out of reach of any company except for one that has a huge use case already. And what you really want instead is to make it so that that entry point is free. That would be ideal, like a global entry point that's free. So that led us to say, well, the only way we're going to do this is if we build virtualization into Cockroach. And that led us to the idea of serverless. It's really like, hey, you can actually have a huge physical cluster spanning the globe. And then we can create multi-tenancy in that and provide virtual clusters that take a whatever arbitrary slice through that physical footprint in order to give a early startup, let's say, or just like the first iteration of a huge company's use case, or a huge company using one big Cockroach cluster to provide serverless clusters to all their developers or all their use cases, so that you have multiple production apps running in the same cluster with very good isolation, where they balance the peaks and troughs, so you have much better utilization. Or you give every developer the ability to create 100 clusters a day, because they're doing CI/CD and they're doing large-scale testing and the same kind of physical footprint that they use in production. All these things are amazing new capabilities if you change the consumption model. So it's kind of like the big things where we're going to use SQL. This needs to be global, and then it's like, how do we make it so that you can give Cockroach clusters to everyone with extremely low friction, both in terms of cost and sort of the expense of spinning something up in terms of time.
That's awesome. No, that makes a lot of sense. And I think one of the things that one of the things that you mentioned as a thing that you folks are working on early on, just that kind of the NoSQL versus SQL thing. I remember when we started building Hasura as well. We started building Hasura to support a JSON store or a NoSQL store, and then we realized that nope, this is a lot of unnecessary complexity that we're having to deal with at this layer, which is actually just better done if it's pushed down to the data layer, because the data layer knows that persistent storage layer, the database layer knows how to handle some of these problems much better, and trying to solve those problems at this kind of API tier is it's not going to be the way of the future, right? And it was around that time also that systems like Cockroach were starting to become known, right? We're like, oh, okay, we're going to start making a SQL-like interface available, a schema structured interface available that will handle some of that complexity up front, and that really eases kind of the way people think about application development. So I think that was an interesting shift to that kind of happened for a whole bunch of people, I think, at the same time. So that was awesome. As you kind of think about these inflection points and where we are today, right? So let's say I'm an application developer or an architect today, and I'm thinking about an application where I do need to have, I will have this kind of a requirement of having a global architecture, or resiliency that has to span multiple data centers from day one, and that is a requirement. But I am starting, and I am going to start small. What would be kind of the way that you would help this architect or this developer orient themselves in the way that they would think about the trade-offs of building with a system, like Cockroach, right? Of building with a system where they are going to have to think about a certain way of partitioning their data, or certain kinds of trade-offs in managing and in working with their database, right? So what would be kind of your advice to them to orient themselves beyond assuming that they are familiar with working with a single node Postgres-like system, right? And they're like, yes, I know how to use this system. I understand the trade-offs. I understand how to design my application. And I understand what to do on day 0, and then what to do on day 5, and what to do on day 10, right? What is that framing that you would want to provide to an architect today, right? And the way that they should now start thinking about their application if they're trying to go serverless and be global from kind of day one?
That's a great question because it has, I think, deep technical implications. And it is definitely difficult to move from the assumption with a complex application built around it, but with the assumption that there's a single node database that's sitting right next to the application server, because there can be lots of behavior from the application where if there's actually latency, because you've changed the database to something like Cockroach that's now geo-replicating across availability zones in a single region, that can add 10 milliseconds of latency to your writes.
Yep.
Right? And it just, whereas previously it was 1 millisecond.
Yep.
Now, or less than 1 millisecond. Right? So that actually can be problematic. Now, the benefit, which I will stress right now, is, of course, with geo-replication that's consensus-based, you actually have an ability to lose one of those availability zones and have complete business continuity. You're not going to a slightly older version where you might have a post-mortem that's required for the application because you're going to an asynchronously replicated failover. And so that's a really profoundly powerful change. However, if you've got 10 milliseconds, or maybe it's even a little bit more, 15 milliseconds on a write, and if the application is doing a whole bunch of serial writes in different transactions, which if you use a microservices-based architecture in a sort of naive fashion, can really be a common occurrence, then those things can add up quickly. And God forbid you do 100 of them, you're talking about a second of latency, right? So that is something to keep in mind. Now, if you're going to start with the assumption that you want to go global and you want to go geo-replicated and so forth, it's a lot easier. I think moving an application is more difficult. But when you start doing it, what you really have to be contending with is, what are the latencies that we're going to have to deal with? Let me give you an example. Let's say that you have geo-partition tables, because most of the time, all of your Australian users' data should only be in Australia, and all of your UK users' data is only in UK, and US similarly. If you never expect that there's going to be any sort of cross-continent transactions, then it's pretty simple, right? A request comes in Australia and it's got all the data it needs in Australia. So it's fairly straightforward. But if, let's say, it's a multi-user game or some sort of communication that can exist between users, and you certainly don't want to prevent it, you just have to be aware that, well, now you're talking about longer latencies, because the data for the UK user is going to have to be fetched from the UK if the operation is running in Australia, vice versa, and so forth. And that can be a significant latency. So the last thing you want to do with that is to have a naive application making lots of queries. Instead, what you'd like to do is make sure that you're fetching a bunch of things with a set operation in SQL, as an example. Right? Let the database do the work, and it can schedule all those in parallel. Cockroach does a bunch of things automatically to pipeline and conserve round trip latencies and so forth. So some of it's taken care of, but if you don't understand the underlying dynamics of what can happen in your system, then you can end up with sort of pathological behavior in those end cases. Another thing about microservices, because that's a very popular direction for folks, is just that you have to be careful how you define a microservice. Like making a microservice kind of a nano service is, I think, an anti-pattern. Right? If everything's split into like databases per tiny little chunks of execution logic, then you kind of never get to do a transaction that is, just getting the data it needs from a single database. Instead, your application layer is doing things that are non-transactional, because in the course of servicing one transaction or one operation for the end user, say clicking a button in a mobile app, is to go to this service with an API call, which might mutate something, this service with another API call, this service, and you're doing them all serially often, and maybe sometimes you're experiencing a latency on this. Boy, that adds up. Plus, if you fail midway, then you might have mutated some things, not other things. So really, when you think about microservices, it's best to think of them as having sort of little nano components in them, but where everything can be bound into a single transaction that in a common operation. So you have to be careful that you make those things idempotent, so that between services. And it's like, basically what I'm getting to, the point here is you need to do that whether you're using something with geographic latencies, like a global data architecture using Cockroach, or there's other databases that do that sort of thing too. You need to think about the same kinds of things there, when you're building from microservices, you do, even if you just have a database that's right next door, but you have lots of them, because you're actually talking about losing the guarantees the database is providing. So it's not that much of a stretch. I would argue that in order to really build modern applications and make them truly performant as their complexity scales, you need to have a reasonable familiarity with what's going on under the hood. And when you start introducing these kinds of latencies, I think that's the biggest thing that you have to contend with. Now, I will say that it's possible. In fact, there's ways to make it easier and easier, and we've been investing quite a bit in that direction. Just in terms of thinking, how can we make global data architectures using Cockroach kind of like the same level of complexity as it is to add an index? But as you know, I'm sure many developers of database-backed applications are relatively new to SQL or relational models and so forth. They don't always know the right way to add indexes and so forth. And so it's really good to have good observability where they can see where the time's being spent, and even make hints and suggestions about, hey, you should add an index here because you're doing full table scans and so forth. But people come up the curve, and they learn how to use indexes as they're becoming more mature in their abilities to build these kinds of applications. The same thing's true with this global problem. We thought about how do we build the primitives in the database so that the complexity is about on the same order as it is to add an index. So it's kind of like we have survivability goals, and we have these things about that makes it really easy to add regions and create sets of regions and to partition and so forth in ways that are that we've simplified things down. Like the way that when we started, we just let you configure everything under the sun, and you can still do that when you peel back the layers a little bit. It was kind of like trying to pilot a space shuttle. It's like this huge instrument panel where you could do all kinds of things that would probably cause you to crash in a fiery explosion. And we've simplified that down so that it's more like driving a Toyota or something like that.
Got it.
No, it's like there's not that many controls anymore, and you can get a lot of the benefit.
No, I think that makes a lot of sense. I think one of the other questions I had was, and kind of from the point of view of an application developer, there's kind of this. We talked a little bit about kind of like this global architecture, like a global data architecture, and getting into that from the very beginning and thinking through that, right? There's another element also, which is that I might not need kind of a global architecture, but I might need this ability to scale out, right? And just raw scale out, even if it's within the same region, within the same data center, right? How different is that from a data modeling point of view or from an architecture point of view compared to when we think about kind of like a global architecture or not, right? Like I'm guessing like some of the ways that we think about latencies are different, but I'm guessing you're still thinking about some nuances to data modeling, right? Like what is that like?
So just scale out is relatively straightforward. In fact, I'd say that you wouldn't expect with scale out to have any kind of significant additional penalties. Now, there are certainly some, right? If you just compare Cockroach as a single node, for example, not even doing any replication, to Postgres as a single node, Postgres is faster. Right? And the reason is just because Cockroach is doing a lot of encodings and decodings and things because it's expecting that things are going to be distributed. So it actually pays a higher cost, but think of it as kind of like a coiled spring. Right? There's potential energy there that can be released, and there's a cost to it. And so that is it's not significant, but it's non-trivial, right? The amount of extra cost that you pay just in terms of doing like a transaction that reads a bunch of different things, combines them, does some writes and so forth. You're going to be paying an extra tax in order to have the capability of making that so that you can do 10 million of those a second, right? Because you're going to have to involve 40 nodes or something like that. But you can go to 40 nodes. You can go to 200 nodes, and so you can do massive scale. So but once you're at that massive scale, you're not necessarily. It pretty much is the same in terms of the overall latency. Now, when you're talking about having 200 nodes that are participating, something could go down. That's sort of what you expect when you have that many nodes. Occasionally, things go down. And that might cause a little bit of latency as things are rerouted, or there's new equilibrium, or the new leader election, or whatever.
Right.
So there's
Right.
there's things in a distributed system, but it's supposed to be resilient to those, and that's kind of
Right.
its huge benefit. So
Right.
there's always these trade-offs, and so even at that level, just getting data intensivity scale, there's at least a little bit of a trade-off. But you shouldn't have to think harder about your data modeling for that. It's still the same principle, and you're just talking about some additional milliseconds added
Got it.
to the latency, as opposed
Got
to when you start thinking about geographic latencies, like you're really doing the geo replication, or you start to do geo partitioning, and you're doing
Right.
transactions that are cross region and so forth.
Right.
That's
Right.
when you have to be cognizant.
Got it. Got it. But from a data modeling point of view, is it from the point of view of the application developer, does it stay the same, or am I starting to think about things like, do I need the equivalent of a sharding column or something that will allow me to indicate to the underlying system of how that data should start getting split across nodes, right? Like, is that an orientation, or is that some learning that needs to be done on the point of view of the application developer? And what are the best ways of kind of thinking through that?
Yeah, no, that is actually a point of concern. So in general, Cockroach is really good about doing all the sharding for you. But if you're not aware of some of the pitfalls, then you definitely can get a sharp edge. Let me give you an example. If you rely on sequences in order to get monotonically increasing IDs, let's say, those actually have to go to a single set of nodes, basically, that control what we call a range. It's a section of the overall key space that holds that sequence. And obviously, it's one place, and it's got to be very consistent, because it's got to be monotonically increasing. You wanted everyone to feed from the same sequence. And so that sequence can become a hotspot. If you've got 200 nodes and huge numbers of transactions per second, they're all trying to hit that. That has to service huge amounts of sequence numbers, huge amounts, right? And eventually it can't, because that node can only do so many things at once, or that set of nodes. So there's ways around that, right? You can allocate blocks of IDs. And so then those are cached and used, but then the time between different application servers can get intermixed, and the things aren't always monotonically increasing in relation to the absolute timestamps. So that's something that you'd be aware of. Another option is that you can use sort of distributed system safe sequences. They're not necessarily monotonically increasing, but they have similar properties, because they're composed of a timestamp and then essentially like a
machine ID or something.
A unique node ID.
Yeah.
Exactly. So it's a totally unique number, and it is mostly monotonically increasing according to timestamp, because it involves the timestamp, but it doesn't require that you go to a hotspot in order to allocate it. So when you're thinking about how to build on a system like Cockroach or Cassandra, or there's plenty of other distributed systems now, you really do want to think about some transitions in terms of the primitives you're using, so you don't create hotspots. And there are other examples of this. And I think that the key thing to it's important to understand a little bit of how Cockroach does what it does. Let me give you another example. If you're just writing data in what's going to be just
append only type thing.
Yeah, it's essentially like a linear sequence.
Yeah.
Like let's say that your primary key has as its first component a timestamp. Or something like that. Then everything is just going to be being written continuously to the same chunk of, we call it the range again. The same range is going to get another hotspot, and then that range will get filled up, and it'll go to the next range, and then it might be another set of nodes that are replicating that range. But then those set of nodes become the hotspot, and then go on and so forth. So you got to be careful about that if that becomes a super heavy write table. Instead, you'd want to use more of like a UUID. And the problem is, if you use a UUID, then things aren't ordered in the way that you want them to be ordered. So there are concerns that you do have to become aware of when you use a distributed system. But again, I'd say that these things are tractable. Let me just give you one little data point, which I think is pretty interesting. Spanner is not very well used in GCP, Cloud Spanner. So that's Google's database that really inspired Cockroach. It's got a very similar architecture. It hasn't gotten that much usage as a public-facing cloud database as a service, but internally at Google, Spanner is used for virtually everything. And it's probably one of the most used databases in the world, just because Google's data needs are so unbelievable. I mean, if you actually look at the number of database cores that are in production in the world, Google probably owns a large fraction of them. That one company owns probably maybe even a double-digit percentage. I don't know. A vast number of the database processing in the world is done by Google in Spanner. And they use it for virtually every kind of use case. So anytime you're using a Google product, you're hitting Spanner all the time behind the scenes. So yes, you can build anything with this kind of thing, but you do have to think about it a little bit differently than the assumptions that most of us have kind of baked in over many years of building database applications, where the database sits right next to you and it's just one thing and you scale it vertically.
Yep. No, that's awesome. And I think that's one of the things that gets me really excited as well about the layer at which kind of things like Hasura sit at, right? Because for example, it's so interesting that so many of the when you think about scaling, you think about scaling out systems like chat or whatever, right? You think about partitioning, you think about so many different types of workloads. A big chunk of that really boils down to how you are managing sequences and ranges, right? Is your workload a sequence range query or mutation type workload, or is it like a point object style workload, right? And that becomes such an interesting way to think about what your requirements of the underlying layer is going to be. And one of those things with sequences, especially, having a monotonically increasing ID makes things so convenient, but it's almost impossible to do in a distributed system, because you're kind of creating that centralization problem again, right? And you're going to have to pay that penalty somewhere. And like you said, I think Twitter called it like a snowflake ID or something, right? That they had, which is this timestamp plus machine ID plus whatever that is sort of partial ordered. Absorbing that concern at a middle layer, like at a Hasura, where writes kind of go through Hasura, right? Where Hasura can kind of straddle that for you is a very interesting idea to me, because it kind of takes that burden off developers and says, you can just start thinking in terms of primitives of, do I have a rangy kind of workload, or do I have a sequencey workload, right? And hence, what should I be doing at the modeling layer? And a system like Hasura can create a good contract with a system like Cockroach to manage that well, right? And that becomes it's a higher level of abstraction for the architect or the developer to think about. And the underlying nitty-gritty of how that's actually managed gets taken care of by these two systems, right? So I think that style is going to be amazing, right? And for me, especially like providing
that makes a lot of sense.
Global sequence ID is amazing, right? That kind of abstraction would be absolutely amazing. When we kind of think about, speaking to what you were talking a little bit about earlier, when we think about like microservices and nanoservices, and each nanoservice is its own database type thing, right? One of the things that is an interesting tension that we've observed in the ecosystem, right, is that this big benefit of one of the aspects of serverless, which is working with, say, serverless functions, right? This massive benefit of being able to work with something like a serverless function is that it's hyper independence, right? It's saying that me as a developer, I can write a piece of business logic and I can own that end to end. I can deploy it, I can own it, I own the code inside it, right? I can own the logic inside it. I'm responsible end to end for these functions that I've written. And that's interesting, right? Because from an organizational point of view, it kind of really just stretches, it takes that whole microservices kind of idea to an extreme, just from an ownership and accountability point of view, right? In this kind of a future, if this was to become a trend that keeps kind of getting amplified, in this kind of a future, where do you think it's going to land? Is it going to be like, there's going to be a lot of different serverless functions that people are writing that interact with the same database system, for example, like a Cockroach, right? Is that what's happening? That all of these different serverless functions that are talking to the same database? Is that what you're seeing, or is that a plausible future? Or how do we straddle that tension?
Well, it's a good question. I don't know all of the different usages of Cockroach out there. I imagine that there's everything on either side of the spectrum and everything in between. There's very clear desires and reasons why you'd want to have that really independent ownership of the sort of inputs, outputs, and potential sort of side effects of a particular bit of execution logic or application code. And it's nice in theory, at least, to build lots of little functions where that ownership they're completely independent.
Right.
But as you know, because this is basically a way that people try to build their code as well, right? You want to list all your expected variables, your return values, like any side effects and so forth, and you put that in the contract that's in the comment, and you're mapping everything out, and then a little bit later you realize that those things weren't quite right, and you change them, but then you didn't change something else, and like 2 years down the road, it's all kind of a spaghetti, and you violate a bunch of abstractions because this just didn't end up being the right thing you started with, or it's too inefficient. And the same thing happens, let's face it, with microservices, right? You don't get to keep that independence forever. I think there's just got to be, in every development shop, right, just a different way to do things, slightly different across all the different worlds. And I don't think there's any right answer, because it's hard no matter which way you go. It always starts off being like, this seems like the greatest way, this is really going to scale well for us. And then, as you go, you find that whatever you chose has some benefits and some, problems, right? And so the biggest thing is, you put more into a piece of application logic, and I think you have more flexibility in terms of the data sources that you touch, and your understanding of what those side effects are, and whether you make it idempotent or the whole thing can be transactional. And the more things that you can grasp at once in a single scope of execution logic, the more like kind of long-term understanding you have of what it's actually doing, and if you made a mistake, how you can fix it and so forth. The smaller you make the execution logic, the simpler it becomes. And that's obviously a big benefit. But then the more, I guess, the more you have a sort of a dissolute set of side effects that it be very difficult to tease apart when things become more and more complex, and you get new people, and all the people that wrote it originally leave and so forth. And then you call one thing which can call a bunch of other things, and trying to figure out what happened and how to back out if something fails midway can become next to impossible. So it's like whichever way you go, you have to just stay on top of it, I guess, is the best way to put it. And so I say that, like, we have people or companies in particular that really are going on both ends of the spectrum, all the way to, of course, using the monolithic application server still, just because there are benefits to it, as much as people hate it as well, right? Both things. I guess the main takeaway here is that as your application complexity scales, you have more problems. There's just no way around it, right? And so be better happy or equally unhappy on both ends.
No, makes sense. I think, oops, I lost you for a bit. Are we back? Hey, Spencer, can you hear me?
Back, yeah, sorry. My internet's not doing so well. Am I back?
You're back.
Okay.
Yeah, I can hear you. Just give it a second for the internet. Okay, cool. So I think, I think kind of in that similar kind of topic, right? One of the other things that I see a lot of folks kind of trying to figure out what stance they should take, right? And how they should think about it from a day zero point of view, like I'm just getting started, versus like day 5 or day 10, like when systems are kind of scaling out, there's more usage. Is a similar tension around whether they want to offload that activity into kind of a distributed transaction that the data layer will handle, right? Versus a workflow, right? And a workflow between systems that are executing kind of independently, right? Where if you think about it from an architectural pattern or something like a CQRS like system, right? It's that, we're going to send our writes We're going to queue that up into one service. That one service will try its best to perform its part of the logic and then send that across to another service, maybe over an event-driven system so that things can be retried and replayed and stuff like that. And so everything is going to be eventually consistent. They're all going to materialize their writes into some form of either a physical or a logical view model, and then we're going to read from the view model, right? And so it's eventually consistent, and there's kind of a read model that you're reading from, right? Versus this idea of this kind of resurgence of this convenience that things like Cockroach offer, where you're like, hey, I can just start, I don't need to do this distributed transaction. Because I can just guarantee that consistency now within one scaled out system. I can kind of handle that myself, right? So as an architect, if I kind of came to you with this question, right, how would you lay out my decision tree in front of me, right? Like, how would you give me a decision tree to be like, Tanmai, this is how you need to think about this, or the questions that you can start asking to figure out which route you want to take?
It's a good question, because I've built both kinds of systems. And when we use DynamoDB, for example, in the startup I did, we went in that sort of microservice-based approach where we tried to guarantee that everything was idempotent, so that if we retried the whole operation, it would become consistent, right. Even if it was partially consistent due to a failure. And those failures, by the way, often happen because the application code has errors, as opposed to a database dying or something like that. It's more common for application errors. I'd say that we spend about 33% of our time, at least a third, just trying to fix problems with making idempotency work. It's very, very difficult to do that at application layer. Assuming that you just really want things to be consistent. And by the way, if things become inconsistent, and I'm sure many people have experienced this, your application code has to account for that, right? There's a lot of conditional blocks and error handling and tries and accepts and things like that, right? And so you're constantly saying, well, if something weird happened, I'm just going to back out and maybe return a nice error to the user or whatever, and then hopefully this thing will be rerun in the future. And what you really don't want to do is to block the system up so that other things can't process. But it ends up being quite expensive. And again, as complexity scales, I think that goes up. Now, the benefit of that, aside from the fact that we kind of had to use DynamoDB, so we're sort of, we didn't have an option except for to, I think, try that model. Right. But the benefit was, to your earlier point, that there could be chunks of code that were treated very independently.
Yep.
Which just makes the whole debugging and adding new things and so forth process simpler. Yep. But I think that I've also seen examples where the database is much more monolithic, at least in concept. Yep. And so an operation that was running could start a transaction, and then within a you really want to modularize your code, but within a single application server, within that transaction, everything can be done.
Yep.
And that lets the database do all kinds of things for you.
Yep.
One, it can do all kinds of things in parallel, especially if there's geographic latencies. It also can, it's all or nothing, right? That whole transaction scope controls the idempotency for you, and no complexities added there. Yep. And like I said, I think that it really just depends, I'd say, on the organizational bias of the group of engineers that are building. Let's say you have multiple companies that are working on things. It's very clear that you'd want to separate these things out and have different databases, different scopes of like authorization and control, and you just have to make that stuff work together. Mm-hmm. And so that there's like contracts that you have to establish and so forth, and that can happen within a big organization as well. So where you have a tight-knit group of developers, I would argue that they should be working in the same code base with the same database. Where you're splitting across sort of organizational boundaries, then I think that's really important to separate those concerns, have the ability to put in security and authorization layers that are appropriate and so forth, because you just can't control the sort of, there's Byzantine failures that can happen there, where you have bad actors and all kinds of other things, and you certainly have to protect your sort of slice of the larger puzzle.
Got it. Makes sense. And so it kind of like largely deciding which way to go is really more of understanding kind of how the state of the organization today and where the organization is, kind of how it's going to evolve, and using that to kind of factor into using that to kind of take a call on how we want this technology stack to kind of look like, right? And I think it kind of boils down to that decision. That makes a lot of sense. I think a lot of these problems are ultimately problems of ownership and accountability, right? Of figuring out like who do we want as owners of things of highest agency, and then how are they going to be accountable for the work that they do, right? And whatever that structuring is like can help kind of decide, which side we lean on, right? Whether we do
Yeah, and by the way, that's just my personal opinion. I mean, we have customers that are absolutely doing both, and either, and maybe even neither. I'm not quite sure about that last one, but we definitely have seen all sorts of things work. And
yeah, exactly.
That would how I'd come down, just because that's where, like, I think the database can do very powerful things, and it's necessary that the database does even more as you start moving into truly global data architectures, because that's where, man, if the database understands what the latencies are, where different copies of the data are, where things can be scheduled, what can be done in parallelizable modes, and that is very powerful, right? Does the database always do the right thing? No, but by giving that layer of abstraction free reign, you can add that intelligence as time goes by, and that's really powerful. So I think that some of the new methodologies, and microservices is a big one, can really pierce that abstraction, or just sort of invalidate it, so that you just have many different databases that are not interacting, and all of them are accessed separately. And that I think that will rob you of some of the ability to truly scale applications where they're going to need to go in the next decade.
Yep. Makes sense, right? And I think, and then kind of on that vein, when you think about the next set of, like the horizon of the next set of problems to solve, to kind of keep pushing the envelope on what it means to be kind of global, kind of have a global architecture from the very beginning, or be serverless from the very beginning, in terms of being able to scale out and starting with zero and then scaling up, quote unquote, infinitely, right? What are the key kind of inflection points in the industry, and the key technical problems that you and Cockroach are thinking about, that you're excited about, right? That there's like things to solve and things to watch out for?
Well, the big one for us was cost, right? And I think we're getting there. Our serverless product is still in beta, but our GA is going to happen this summer. And then when you look at the GA and you look at all the things that could be built on top of it, there's years of development ahead, which is exciting. Really, one of the goals with that is, yes, the pricing is incremental. It starts free, and then you pay exactly for what you use as you scale beyond that. So that part's great, but you also want the complexity to be incremental.
Yeah.
Kind of like the really simple UX, where if you click on the advanced features, you get like a whole bunch of stuff that you don't need to know about on day one. But that's really easy to then start to use as you understand the basic set of tools well enough, and then you want to start chipping away at all the advanced things in order to get more done, or more efficiently done. And that's exactly how we want these advanced pieces of functionality to work, like global. Hey, you start in one region, which is exactly where you're actually accessing the Cockroach serverless cluster creation page from. That's where it's going to default to. You're on the East Coast, or you're the West Coast, or whatever. But then you don't have to worry about regions or anything like that. You don't have to worry about latencies or anything. But as you say, hey, we'd like to add one more region, then that's, first of all, extremely easy to do. It's really just selecting the additional region, and all of a sudden things are there. And then even then, when you have the other region, the thing still behaves exactly how it used to behave. In order to use that other region, you have to start to accommodate it. Say, okay, now we're going to take this table, which currently is just, say, East Coast, which is where you started. We'd like to make it partitioned by row. In other words, every row can either be in the East Coast or the West Coast. And in order to do that, you say, here's the row or the region ID for the row, or we're going to use this particular attribute in order to determine whether it's East Coast or West Coast user. And as soon as you do that, then it is able to just split your data model, and it does it very automatically.
Yep.
And then you add a third region, and that actually very easily slides in there, and because you've already said that that particular table is regional by row. Now you've got a Europe West region, let's say, right? And so that you might not have any rows in it to start, but adding that other region into that database makes it so that you can immediately create rows that are domiciled in US or European West, just by adding the appropriate tag to specify that's the region for a row. There's a lot more detail there, but that's the kind of thing that we're looking for in order to make this tractable for people. Start easy, start the way that you're used to it. And then in order to get the more advanced functionality, you're really just opting for very simple SQL changes, just a SQL alter table, for example.
Makes a lot of sense. I think I like the idea of like pricing and cost can scale incrementally, but complexity should scale incrementally too, right? That's just a nice way to think about developer experience as well. So I think that's really nice. And in terms of inflection points, do you think that there are inflection points that are happening in the industry, either on the application development side or on the data side, in the way that kind of workloads are evolving, just because of the way the data landscape itself is kind of exploding, right? Where there's there's OLTP and there's OLAP and there's hybrid and there's like 1 million things in the middle. Are there other inflection points and evolutions of other systems also that you're thinking about in these landscapes that might affect kind of the industry and like your roadmap in particular?
It's a good question. I do think that when I think about different little projects I'd like to build, I always think about what would be the easiest possible way to do it. And I look at Cockroach Serverless as being really geared towards that vision of this, not having to put a credit card in, get a database that can actually be used really at the edge. And then you say, okay, well, in order to use that, I need to have an application that's also running next to those database nodes, everywhere that there's database nodes in every region and so forth. And let's say you're trying to build a Jamstack style application. Right? So now you have React code that's running in the browser. You want to have, let's say, Node.js code that's running on application servers. All of those have to be running near the database and know how to talk to the database. You kind of want to, I think, invert that and think of it more from the perspective of there's a tight integration between the application code and the database in such a way that, for example, when you load the assets that power the browser, it just gives you all of the APIs you need within the JavaScript that you access in the browser code to access your entire data model with the right authorizations and things. You're not dealing with like tokens and things like that and talking to HTTP services. It's just JavaScript, like function signatures, and you're just calling them. And there could be some delay because not all the data could start off cached, although you could have a nice bootstrap amount of data for whatever that user entity was that loaded when they click something. But now the programming task for that React developer is extraordinarily straightforward. Right? Like everything is functional as opposed to being done with these promises and underlying HTTP things and so forth. Now, of course, that happens in the back end, but it's kind of like how can you really turn this around so that the application developer just writes code? You have your data model and you have your code, but you're not trying to wrestle with a distributed system. And that's really that's a very interesting future state, which I think would make people's lives a lot easier, including my own.
No, I think that makes a lot of sense. And I think that idea of like having developers just write code and having everything work is awesome, right? And we talked about a bunch of things on the distributed system awareness and I think topology awareness as well, right? Like if that topology awareness can just be like just be handled, right? So that it's my code and it runs and systems can figure out where to run this code and how to route it to the closest data node possible, right? Would just make life amazing for developers, right? So
and hey, I noticed that like things are being very pathological here. These sets of queries are taking way too long. This is what we suggest, or at least just pointing it out. Those kinds of observability capabilities are totally doable. we started adding some of them. But in that world where you do make it so that you're trying to deliver on the promise of developers writing the code on their laptop and then scaling it globally, where they pay exactly for what they use, the whole application stack, the whole data stack, that is achievable, but only if you've got some relief valves, right? Because things can get weird when you start talking about global data architecture, and you just need to point that out to the user. Like, this is taking too long. Perhaps you need to have this kind of partitioning that you're not doing, and so forth.
Yep. And expose the kind of right levers and toggles to them with that insight, right? So it's like, here's what we're observing. Here's the set of like toggles that you have to think about this, right? And then people can start figuring that out. That makes a lot of sense. In the last few minutes, just quickly taking a few questions that have come in. I think two questions around Hasura plus Cockroach integration. It's in development, so there's stuff that's happening, and I think that's going to be super exciting. There's a few kind of capabilities that I think the teams are thinking about, which is especially on kind of our eventing side and those kinds of things. So we likely might have like our first integration that doesn't support eventing just yet, and then in the next piece have that integration with Cockroach's CDC as well. To power those eventing things. So that's the first question there, or the first two questions there. The second question, I think, Spencer, for you on the Cockroach side of things was, is there a difference in read latencies that people should think about between serverless instances and dedicated instances? And perhaps more generally, is there a set of trade-offs that people should think about when they're using serverless versus dedicated instances with the multi-tenant approach that you have at Cockroach?
That's a good question. Right now, there shouldn't be any latency differences between serverless and dedicated. They're really similar under the covers in terms of how they do things. So the biggest thing with latency to the database is just to make sure that your application logic is running close to where the serverless region that you've chosen for your serverless cluster. So you don't want to do a cross-region communication to the database, because every time, SQL is very chatty. So as you open a transaction, you read. If you're jumping across regions, you're going to have very, very high latency. So it's very important that you put them in the same availability zone. And that's relatively easy to do. It's as easy as it is and as necessary as it is when you're using dedicated. In terms of the difference between serverless and dedicated today, they actually are somewhat different. So we added serverless recently. In the last couple of years, we've been working on it, and that uses the multi-tenancy capability in the core Cockroach database. That actually precludes some of the capabilities that are available in dedicated. Like, for example, distributed SQL, where we schedule parts of a distributed query close to where the actual data is, and they run on the same node where the data is stored. So that gives it a very efficient operation in the database. That's not available in multi-tenancy right now, because we separate out the SQL into pods that are not coincident with the data. We're changing that. We're making it so that there is an ability to use distributed SQL in the multi-tenant world as well. But that's for really big queries where that really impacts the performance. But that's just one example where there's some differences between the two, and we're closing those gaps. So when we do our general availability release, which is coming out this summer, so in just a month or two, that is actually going to eliminate some of the differences. For example, you couldn't do your own custom scheduling of backups and restores within a serverless cluster. And that will change in the general availability release. It's basically the minimal viable product for production usage, which will come out this summer. And then over successive releases, it will be closing all the gaps between dedicated and then adding additional capabilities.
Got it. Awesome. No, I think that makes a lot of sense. Yeah, I think otherwise, if folks who are watching the recorded session or folks here, if you'd have questions for, if you have any follow-up questions or topics of discussion for me or Spencer, feel free to reach out to me on Twitter. Spencer, are you open to conversations on the socials? Do you usually hang out on LinkedIn or Twitter, or is there a
LinkedIn? I do. Yeah, but there's a Cockroach DB Twitter account.
Perfect. Awesome. Yeah. So there's that. And I'm sure there's a Discord / Slack community that you folks have as well, where folks can pitch in and ask questions. So feel free to kind of engage with us and our teams there. and we'll chat with you then. But otherwise, Spencer, it was great having you here today. Thanks so much for taking the time. This was a super interesting conversation. I'm looking forward to seeing how all of this evolves and how people are going to start thinking about the various trade-offs in the years to come. I think it's going to be amazingly different 5 years from now. It's just going to be completely different, right? So it's going to be fascinating to see how that changes.
Yeah, thank you for having me, Tanmai. It was a really enjoyable conversation.
Thanks, Spencer. All right, bye, folks.
Thanks, everyone. Have a great day.